Okay, so I hope the screen is visible to you. And the topic
Yes,
for
sir.
today's lecture is CPU scheduling. And in today's lecture, we will focus on the basic concepts. What is a CPU scheduling? What are schedulers? What are the different type of schedulers? What scheduler do? And how exactly the overall process of multi-programming and multitasking, which we discussed earlier, actually happens. And today I'm just going to cover all the basic concept, which is very much important and required to understand next few lectures. And from next lecture onwards, we will discuss various CPU scheduling algorithms. So for doing those algorithms, for understanding those algorithms, this lecture of understanding the basic concepts of CPU scheduling is very important. So let me move further. Okay, so as we know, the objective of multi-programming is basically to maximize the CPU utilization. As we all know, multi-programming means we can have multiple processes in RAM which may execute simultaneously so that the CPU should not sit idle, and the basic objective is to maximize the utilization of the CPU. Similarly, we have the multitasking or the time sharing systems where the purpose is to switch the CPU among the processes so frequently that the users can interact with each program while it is running. So basically, multi-programming and multitasking, we do not want the CPU to sit idle. We just want that at any moment of time, at least one process or at least some of the process may execute concurrently, so that it must increase the CPU utilization and it must make the processes run faster. And to meet these objectives of multi-programming and multi-scheduling, we need to have a process scheduler. So the task of this scheduler is to select an available process from the set of available processes for the program execution on the CPU. So scheduler is the thing, is the concept which is going to select the process which we are going to allocate to the CPU. And as we know, we used to have a single processor system according to our course. And in a single processor system, there will never be more than one running process. So as we have discussed in the process state diagram, in only one process at a time in a single processor system can be in running state. So the task of process scheduler is, out of the available processes which are ready to execute in the RAM, in the main memory, which process is to be assigned to the CPU for the execution. So this is the basic purpose of any process scheduler, to choose to pick any one process from the RAM and assign it the CPU to that particular process so that the process may execute. And if there are more processes, as we know, in the multitasking or in multi-programming system, we may have more than one processes in the ready state, in the random access memory, waiting for their turn. So in the case of all those things, if we are having more than processes, the rest of the processes have to wait until the CPU is free, and only one process at a time will be assigned to the CPU. So all these things we know, and we have studied earlier the entire concept of multi-programming and multitasking. So the new thing which we have to learn here is the CPU scheduling concept. And for performing scheduling, we used to have a scheduler, and the task of the scheduler is to choose any one process at a time and assign that process to the CPU. And this process is continued for so many number of times. And if I talk about in detail or in the concept of CPU scheduling, we used to have different kind of scheduling queues. So the very first queue is the job queue. So you must have studied this data structure queue in your data structure subject. So a queue is basically a first in, first out data structure, and there are different varieties of queue such as priority queue, and some other queues are also there. So depending upon the availability or the requirement, we used to have different kind of queues in our system in which the process resides. So mainly these queues are divided into three categories. The very first is the job queue. So job queue, if I talk, so job queue is basically, if you remember this particular diagram, so we have new state and ready state. So new state is the state where we used to have all the processes in the hard disk which are created by us. And suppose initially we are in the new state where the processes are there. So the job queue is simply the set of processes which are currently there in this new state, and this particular new state is also known as job pool. So job pool means collection of all the processes which are available in the system. So as you can see here, this job queue consists of all the processes which are available in the system. So in your system, जितनी भी files आपके पास हैं, जितनी भी executable files हैं, जितने भी programs हैं, it can be a song, it can be MP3, MP4, JPG, PNG, all these are the processes which are consisted in this job queue, and basically they all are in a new state until we are going to double click on them or we are going to execute for our requirement. So job queue consists of all the processes which are available in the system. Then second most important queue is the ready queue. So ready queue is related with this ready state, where I just talked about that ready state is nothing. It consists of all the processes which are ready to execute, and basically here we talk about the random access memory. The processes are in RAM, they are waiting for the CPU. So if I talk about this ready queue, so you can see ready queue consists of all the processes which are in main memory and the processes which are ready and waiting to get execute. And generally ready queue are implemented as a linked list, so you must be knowing what is a linked list. And if I talk about the last type of queue, so there is one more queue which is known as the device queue, and this particular queue consists of all the processes which are waiting for a particular input output device. So these are the different types of queues, and generally a process migrates among these various queues. So initially, if the process is in hard disk, that means it is in new state, and we can say that the processes are in job queue. So job queue consists of all those processes which are in the new state, and ready queue consists of all those processes which are in ready state, which are in the main memory, and they are ready and they are waiting for the CPU. Similarly, if any process request for the input output event, so that particular process is sent to a device queue, and device queue consists of all the processes which are waiting for some input output event. So as I have discussed, only one process can be in running state at a time, but many processes can be in ready state as well as in the waiting state. So basically, ये job queue क्या है? This is related with the new state. Ready queue is related with the ready state, whereas the device queue is related with the waiting state or the block state. And as you know, only one process can be in the running state, so we do not require to maintain any queue because CPU के पास एक time पर एक ही process होगा. So this is just a picture of the various ready queue and the input output devices queue. So as I have just mentioned, in the operating system, each process is represented by its process control block, and every process consists of some associated information. So you can see this is process 7, this is process 2, and this is the process control block for all the processes which are currently in the system. And there are some information like the registers, the stack, the data section, the text section which is associated with each and every process, and these are some of the queues. Mainly we are talking about the ready queue and the input output device queue which are concerned. And as I have just discussed here, that ready queues are generally stored in the form of linked lists. So this is how the structure appears inside the system. And this is the representation of scheduling. So this is very interesting diagram, and most of the things we are already knowing. So from here I am starting. So this is the arrow. Before this we have a new state, and suppose if we select 2 or 3 processes, we double click on the executable file, so those processes will enter into the ready queue. Now here we are having a ready queue inside the RAM where the processes will be stored, and this is not only the case where we should have only the simple linear queue, that is the FIFO queue. The processes may be arranged here according to the priority queue also. So depending upon the algorithm, this ready queue may consist of many processes which are ready to execute in different sequence. So you can suppose, or you can assume, that there are so many processes which are in ready state, and ready state simply means which are residing in this ready queue and waiting for their turn to get the CPU. And out of those available processes, only one process at a time will get CPU, and once a process gets CPU, it will start executing the instruction. The simplest case is the process do not require any input output task or anything, or no interrupt comes in between, then the process will simply be terminated after completing all its instruction. But as I have discussed in the process state diagram also, that from the running state there are different possibilities. The process may go to terminate state, which is represented using this arrow, but there are some other cases. So this is the first case. During its execution, a process may want to perform some input output operation. So in that case, the process will request for input output operation, and that particular process will be put into the input output queue. So mainly we are talking about the 2 types of queues here which we have discussed in this slide. This is ready queue and this is device queue. So this is the ready queue, which will consist of all the processes which are ready to execute and waiting for the CPU, whereas this device queue or input output queue will consist of all the processes which are waiting for some event to happen, or which have requested some input output process, and after that they will complete their task. And as we have discussed in the process state diagram also, from waiting state always a process go back to the ready state, it never go directly back to the CPU. So this is the first case. Secondly, we have also discussed that in the case of multitasking systems, there is a fixed time slice, fixed time quantum which is associated with each process. CPU is not going to give more than 2 seconds suppose to any process. So after 2 seconds, the time slice of that process expires and it will go back to the ready state. So this I have discussed that when we used to go directly from running to ready. So this was the first case. Another possibility is whenever any interrupt occurs or a process of higher priority occurs. So in that particular case also, from the running state, the process is sent back to the ready state, or better to say ready queue. And there is one more possibility which we have learned in the last 2 lectures. During its execution, a process may create its duplicate, the child processes using a fork system call, and again after the formation of this child processes, they will be sent into the ready queue and they will just wait for its turn or to get the CPU. So this is the overall concept. The different queues are related during the process of scheduling, and this is how actually the process migrates between the various kind of queues. Now this is very important and interesting, the various types of schedulers. So a process migrates among the various scheduling queues throughout its lifetime. So I have just discussed here, initially the processes will be in job queue when they are simply in the hard disk, and those processes will enter from job queue to ready queue, those who we want to execute, and the ready queue will consist of large number of processes depending upon how much RAM we are having. And from those processes, only one process at a time will get the CPU, and again from the CPU during its running state, a process may want to perform some input output operation, so it is going to enter the input output queue, and this is the process that will occur in the throughout the lifetime of any process. So operating system must select for the scheduling purposes the processes from these queue in some fashion. So कोई ना कोई procedure होगा, कोई ना कोई logic होगा, कोई ना कोई algorithm होगी. If I am having 10 different processes from P1 to P10 in this ready queue, so scheduler will select any one process, either P1 or P2 or P10. So कौन सा process choose होगा, so that totally depends upon the operating system, and operating system performs this task with the help of schedulers, and the selection process is carried out by the appropriate scheduler. And now this is most important. We have mainly two types of scheduler. First is the long-term scheduler, and second is the short-term scheduler. Long-term scheduler is also known as job scheduler, and short-term scheduler is also known as the CPU scheduler. So long-term scheduler, short-term scheduler क्या करते हैं, क्या difference है? So just go through this process state diagram. So you can see this is the state new and this is the state ready, as I have discussed previously in my class. So here we are having the job queue and here we are having the ready queue. So in between this new state and ready state, we used to have this long-term scheduler, or better to say job scheduler, and whose task is to select few processes among the hard disk, few processes from the job queue, and put those processes into the RAM, into the ready state. So this is the first kind of scheduler whose task is to choose some of the processes from this new state and put those processes into the ready state, into the RAM. So this is long-term scheduler. Now if we talk about the short-term scheduler, in this ready state, in this ready queue, we will be having so many processes which are ready and which are waiting for the CPU. So here you can see we have a line from ready to running. So here we used to have one short-term scheduler, which is also known as CPU scheduler, whose task is to choose any one process at a time from this ready state, from this ready queue, and assign that process the CPU. So this is the task of short-term scheduler, to choose any one process from ready state and change its status from ready to running, and long-term scheduler choose some of the processes from this new state and just send those processes to the ready state. So I hope the difference between the short-term scheduler and the long-term scheduler is very much clear. So the long-term scheduler selects which processes should be brought into the ready queue from the job queue. New state से ready state में कितने processes को भेजना है, that is the task of long-term scheduler. So that is why it is also known as job scheduler. The task is to choose the jobs from the new state, from the job queue, from the job pool, whereas short-term scheduler is also known as CPU scheduler, because इस केस में हमें किसी एक process को CPU को देना है. So it selects from among the processes that are ready to execute. So ready to execute वाले processes सारे ready state में होंगे, RAM में होंगे. उन RAM वाले जितने भी processes हैं, उनमें से किसी एक process को, because we are assuming single processor system and in the running state we can have only one process at a time. So the CPU scheduler selects from among the processes that are ready to execute and allocates the CPU to one of them. So एक ही process choose करेगा CPU scheduler, बट लॉन्ग टर्म शेड्यूलर और जॉब टर्म शेड्यूलर एक टाइम पे बहुत सारे प्रोसेसेस को न्यू स्टेट से रेडी में लेके आ सकता है, डिपेंडिंग अपॉन हमारे रैम की अवेलेबिलिटी कितनी है कि हमारा ओवरऑल सिस्टम स्लो ना हो, इट मस्ट एग्जीक्यूट as it is. So this is the task. And if we talk about the difference between these two schedulers. So as the name suggests, short term scheduler, short term means very less time. So short term scheduler को बहुत जल्दी जल्दी एग्जीक्यूट होना पड़ेगा, बहुत जल्दी जल्दी रैम में से एक प्रोसेस को चूज करके सीपीयू को देना पड़ेगा. As I have just discussed in the case of multitasking, CPU used to give even less than 1 second to a single process. तो सीपीयू के केस में, सीपीयू शेड्यूलर के केस में, शॉर्ट टर्म शेड्यूलर के केस में, शॉर्ट टर्म शेड्यूलर को बहुत जल्दी जल्दी, इवन इन लेस देन 1 second और better to say in milliseconds, it have to choose any one process from the ready state and it send it to the CPU for execution. Then after the time quantum, the CPU will send that process back and the CPU scheduler will again choose one of the process from the ready state. So this is why it is known as short term scheduler, because the time for the short term scheduler is very less. It has to choose the processes very frequently. And if we talk about the long term scheduler basically works in seconds or even in minutes. So it may take long time to choose the processes from the new state to ready state, but short term scheduler has to be very frequent. It must execute fast so that CPU should not sit idle and we should have the maximum CPU utilization. Another important term and interesting thing is degree of multiprogramming. So degree of multiprogramming simply means total number of processes which are currently in the main memory or in the RAM, and it is totally the responsibility of the long-term scheduler, which used to select the processes from the new state and put them into the ready state. So depending upon the availability of RAM, whether we are having 2 GB RAM or having 12 GB RAM, so there will be a huge difference. So depending upon the amount or the availability of space, it chooses the total number of processes at a time which it can send from this new state to the ready state. So always remember this thing, the long-term scheduler controls the degree of programming. Degree of multiprogramming means total number of processes in the main memory, in the RAM, and it is the task of long-term scheduler to choose the processes from the new state, from the job pool, and put them into the ready state, ready queue, or better to say RAM. So it will always be the responsibility of this long-term scheduler. And it is very important that the long-term scheduler always makes a careful selection. Why? Because we used to have two different types of processes, as you can see in the last point. The first category is the input-output bound processes. So these are the processes which spends most of their time doing the input-output computations rather than the execution at CPU. So ये कुछ ऐसे processes होते हैं जो अपना ज़्यादा time input-output task complete करने में लगाते हैं rather than CPU के पास execute होने में. Another category is CPU-bound processes. नाम से ही पता चल रहा है ये ऐसे processes हैं जो CPU के पास ज़्यादा time लगाएंगे rather than doing other computations. So it is that task of long-term scheduler to choose the processes from the job pool, from the job queue, so that our ready state or ready queue must consist of the mixture of these two categories. अगर सारे ही processes input output bound वाले आ जाएंगे RAM में तो हमारा CPU idle हो जाएगा, और अगर हमारे सारे के सारे processes ही CPU bound वाले आ जाएंगे तो हमारी input output वाली queue empty रह जाएगी. So long-term scheduler must always take a careful decision to choose the process in such a manner so that in the RAM, in the ready state, always we used to have a mixture of these both kind of categories. So I hope the concept is clear to you. What is a long-term scheduler and what is a short-term scheduler? Long-term scheduler का काम new state से processes को pick करके ready state में भेजना, admit करना, and short-term scheduler का काम बहुत सारे प्रोसेसेस रैम में है, रेडी स्टेट में है, उन प्रोसेसेस में से किसी एक प्रोसेस को चूज करके पिक करके सीपीयू को एलोकेट कर देना. सो दिस इज द डिफरेंस. नाउ देयर इज अनदर इंपॉर्टेंट कैटेगरी व्हिच इज नॉट एज कॉमन एज long-term scheduler and the short-term scheduler. So we have another category which is medium-term scheduler. So this is also a very interesting concept. So some operating systems such as the multitasking systems or the time-sharing systems may introduce an additional intermediate level of scheduling. So this medium-term scheduler we do not used to have in the traditional computer systems, but in modern operating system we used to have this medium-term scheduler also. And the basic advantage of having this medium-term scheduler is to remove a process from the memory and thus reducing the degree of multi-programming. तो भाई क्या concept है इसके पीछे? अगर हो सकता है कि रैम में बहुत सारे प्रोसेसेस पड़े हों और उनमें से कुछ प्रोसेस ऐसे हों जो इतने इंपॉर्टेंट ना हो एग्जीक्यूट करने को या सीपीयू को देने को, सो दे आर जस्ट टेकिंग द मेमोरी, दे आर जस्ट टेकिंग द रैम स्पेस. So basically the purpose is that if the process is not going to be execute for so long or it is just taking the memory space, so it's better to send back that process or just to take out that process from the memory so that the rest of the processes will execute fast, or any other important process which is of higher priority must bring into the RAM. So this process of taking out the process from the main memory back to the hard disk is known as swapping, and the process is swapped out from this main memory and later on whenever required it is swapped in, and this is the task of this medium term scheduler. So you can see the advantage of medium term scheduler is to remove a process from the memory, and this will going to reduce the degree of multi-programming, which simply means number of processes in the RAM, and later on whenever required the process can be reintroduced back into the memory and its execution can be continued where it left off. So it depends. If the process is no longer required to be in the RAM, then it can send back to the new state, and whenever required, it can send back to the ready state. So this is the picture of medium-term scheduling. So this particular arrow represents, here we used to have a new state. From new state, the processes enters the ready queue, and from the ready queue, any one process will get CPU, and either this process will terminate or it will enter into the input output queue. Otherwise, if it is not required further, it will be swapped out from the memory and it will be simply put into another queue which will contain all the partially executed swapped out processes. So हो सकता है कि उस process की कुछ instructions execute भी हो गई हो, वो CPU के पास था और वहां से हमने डायरेक्टली उसको रैम से रेडी स्टेट से बाहर कर दिया हो और वो एक क्यू में पड़ा है, एंड लेटर ऑन व्हेनेवर इट इज रिक्वायर्ड इट विल अगेन बी स्वैप्ड इनटू द सिस्टम. सो बेसिकली दिस इज entirely known as the swapping, and this swapping is done by this medium term scheduler. The basic purpose is to remove any process from the memory, from the RAM, and reducing the degree of multi-programming, and later on whenever that process is needed again, so that will be introduced back to the ready queue. So this is the concept of this medium term scheduler. Okay, so moving on to the last topic for today's lecture is context switching. Is another interesting topic where whenever CPU switches to another processes, the system must save the state of the old process and load the saved state for the new process via a context switch. So basically context हम किसको बोलते हैं? Context हम process के attributes को बोलते हैं जो कौन कंटेन करता है? प्रोसेस कंट्रोल ब्लॉक. सो अ प्रोसेस कंट्रोल ब्लॉक consists of all the attributes, all the related information such as process state, process unique ID, the list of registers, the list of open files. So all these are known as context of a process. So basically अगर हम मल्टीटास्किंग की बात करें तो CPU बहुत जल्दी प्रोसेसेस के बीच में स्विच करता है. So suppose if I am having two processes P1 and P2 and both are having 100 instructions to execute. So suppose at first time P1 की 50 instructions execute हो चुकी हैं, and after that it is sent back to RAM and P2 is allocated to CPU. So every time CPU switches between the processes, the CPU must, or the system must have to remember the स्टेट ऑफ द ओल्ड प्रोसेस। P1 की कितनी इंस्ट्रक्शंस एग्जीक्यूट हो चुकी थी वो सिस्टम को याद रखना पड़ेगा। ऐसा नहीं होगा हर बार P1 एलोकेट होगा तो वो स्टार्टिंग से एग्जीक्यूट होना स्टार्ट होगा। तो हो सकता है फर्स्ट टाइम 50 स्टेटमेंट्स एग्जीक्यूट हुई, नेक्स्ट टाइम 70 हो चुकी हैं तो वो 71 से स्टार्ट करेगा। दैट इज द टास्क ऑफ प्रोग्राम काउंटर एज आई हैव डिस्कस्ड। सो context simply means the attributes of any process, the information related with the process, and context of a process is represented in the process control block. And to be very honest, this context switching is basically purely an overhead for the CPU, because for that particular time the system cannot do another useful task or another useful work. So this is context switching. Every time CPU used to switch between the processes, the system must save or store or remember the old state of the process. एंड जितना कॉम्प्लेक्स हमारा ऑपरेटिंग सिस्टम होगा, जितना कॉम्प्लेक्स हमारा पीसीबी होगा, उतना ही हमारा लॉन्गर होता जाएगा कंटेक्स्ट स्विचिंग। एंड दिस इज बेसिकली प्योरली ओवरहेड और द वेस्टेज ऑफ टाइम फॉर द एंटायर सिस्टम, बट इट मेनली डिपेंड्स अपॉन द हार्डवेयर और द आर्किटेक्चर ऑफ द सिस्टम। Okay, so for the today's lecture, now this is very important. The last thing is CPU scheduler. So basically, if I talk about the scheduling algorithms, so there are some decisions when the CPU required to switch between the processes. So as you all know, as I have discussed in the process state diagram, from the running state we may go either to terminated state or to waiting state or to the ready state. So basically from long-term scheduler or from short-term scheduler, or better to say CPU scheduler, we are more interested in CPU scheduling, because बहुत जल्दी CPU शेड्यूलर को कोई ना कोई प्रोसेस उठा के रैम से CPU को एलोकेट करना है। सो दिस इज आवर कंसर्न। सो ऐसा कब होगा, CPU शेड्यूलिंग कब परफॉर्म होगी, CPU शेड्यूलर का या शॉर्ट टर्म शेड्यूलर का काम कब स्टार्ट होगा? जैसे ही रनिंग स्टेट से कोई प्रोसेस चला जाएगा CPU आइडल हो जाएगा, साथ के साथ ही CPU शेड्यूलर को कोई ना कोई प्रोसेस यहाँ से पिक करके यहाँ रनिंग स्टेट में सेंड करना है। आई होप दिस थिंग इज क्लियर व्हेन द CPU शेड्यूलिंग इज रिक्वायर्ड और विल एक्चुअली हैपन। जब तक कोई ना कोई प्रोसेस रन हो रहा है, रनिंग स्टेट में है, दैट इज ओके, दैट मींस CPU इज running the instructions, executing any process. बट जैसे ही यहाँ से जो प्रोसेस एग्जीक्यूट हो रहा था, या तो वो टर्मिनेट हो गया, या वो वापस रेडी स्टेट में चला गया, या फिर वो किसी इनपुट आउटपुट ऑपरेशन के लिए चला गया, दैट मीन्स ये रनिंग स्टेट खाली हो गई, CPU आइडल हो गया। तो साथ के साथ ही विद इन द सेकेंड्स the CPU scheduler has to allocate any one process from here to this particular state. So this is all about this CPU scheduling is. So there are 4 different cases when the CPU scheduler has to take decision or it has to choose the processes from the ready state. So the very first state is, or the very first case is whenever the process switches from running to waiting state. तो भाई कोई भी process run हो रहा था और रन होते होते बीच में there is a requirement for that process to perform any input output operation. तो P1 process यहाँ पे run होता होता waiting state में चला गया। तो जैसे ही यहाँ पे P1 चला गया, the CPU is idle. Now there is the responsibility of the CPU scheduler to choose any process. Second category, as I have just discussed, it is possible that कोई भी higher interrupt process आए, या फिर मल्टीटास्किंग सिस्टम है तो रनिंग स्टेट से कोई भी प्रोसेस अगर डायरेक्टली रेडी स्टेट में वापस चला जाए, तो ये वाला केस भी हमने डिस्कस किया था प्रोसेस मैनेजमेंट के केस में। सो इफ एनी प्रोसेस स्विचेस फ्रॉम रनिंग टू रेडी, तो फिर से हमारे पास CPU आइडल हो जाएगा। सो एट दैट टाइम CPU शेड्यूलर मस्ट चूज एनी अदर प्रोसेस from this ready state back to the running state. So the first case is running से waiting में चला जाए, second case is running से ready में चला जाए, one more case is process terminate हो जाए simply exit करके. So and this is the third case, and last case is this is the terminate. And another interesting case is whenever a process switches from waiting to ready. So let's see this case here. So हमने डिस्कस किया था कि waiting में चले जाने के बाद, इनपुट आउटपुट ऑपरेशन कंप्लीट हो जाने के बाद डायरेक्टली रनिंग पे नहीं जाता, वो रेडी में जाता है। नाउ ऐसा हो सकता है कि वो प्रोसेस जैसे ही अपना इनपुट आउटपुट टास्क कंप्लीट करके रेडी में गया, वो इतना हाई प्रायोरिटी का हो सकता है, इतना इंपॉर्टेंट हो सकता है कि बाकी सारे प्रोसेसेस को छोड़ के या फिर जो भी प्रोसेस रनिंग में था उसको डायरेक्टली रनिंग में रेडी में भेज के वो उसी प्रोसेस को फिर से सीपीयू एलोकेट कर दे। सो देयर आर 4 डिफरेंट कैटेगरीज in which the CPU scheduler needs to take decision that yes, now मुझे ready state से कोई एक process को choose करके running में लेके जाना है। तो वो कौन कौन से cases हैं? Already 3 cases we have discussed. Running state जब भी खाली हो जाएगी तब CPU scheduler का काम start हो जाएगा। First case, running से waiting में चला जाए कोई भी process किसी input output operation करने के लिए। Second case, running से ready में चला जाए either due to any interrupt or higher priority process or it may be because of time sharing system. Third case, सिंपल प्रोसेस टर्मिनेट हो जाए अपना सारा कंप्लीट अपना टास्क एग्जीक्यूट करके, तब भी हमारी रनिंग स्टेट एम्प्टी हो जाएगी। एंड द लास्ट केसेस, कोई प्रोसेस अगर वेटिंग में था, उसका टास्क कंप्लीट हुआ इनपुट आउटपुट वाला, वेटिंग से जैसे ही वो रेडी में गया तो क्या वो वाला प्रोसेस इतना इंपॉर्टेंट था कि साथ के साथ उसे सीपीयू देना पड़ेगा। सो दीज आर द 4 डिफरेंट केसेस where any short-term scheduler or any CPU scheduler has to make or has to take the decision. Now, last 2 points are very important. If you carefully look at point number 4 and point number 1, and the point number 2 and point number 3, can you find any difference between these 2 categories? Point number 1, point number 4, and point number 2, point number 3. कुछ difference है इनमें? If anybody can tell, or if anybody would like to try at least. I have mentioned this thing in my last lecture also, where I was discussing the process state diagram. Anyone? Okay, so nobody wants to try, so just let me explain. Okay, so first case and the last case, process terminate itself, and the first case is the process which is from running to waiting state. तो भाई मैंने लास्ट लेक्चर में एक बात बोली थी आप लोगों को, इन दोनों ही केसेस में प्रोसेस इज गोइंग टू टर्मिनेट और प्रोसेस इज गोइंग टू वेकेट द रनिंग स्टेट बाय इट्स ओन विश, अपनी मर्जी से खाली करेगा रनिंग स्टेट को। अगर उसे इनपुट आउटपुट ऑपरेशन के लिए जाना है तो भी वो अपनी मर्जी से रिक्वेस्ट डालता है, अगर वो टर्मिनेट हो रहा है तो वो अपनी मर्जी से अपनी सारी इंस्ट्रक्शंस एग्जीक्यूट होने के बाद टर्मिनेट हो जाता है। सो दिस काइंड ऑफ शेड्यूलिंग इज नोन एज नॉन प्रीएम्प्टिव शेड्यूलिंग। नॉन प्रीएम्प्टिव मींस हमने प्रोसेस को फोर्स नहीं किया, हमने सीपीयू को प्रोसेस को दे दिया था, प्रोसेस पूरा एग्जीक्यूट हुआ या फिर अपनी मर्जी से उसने सीपीयू को छोड़ के वो इनपुट आउटपुट ऑपरेशन के लिए गया है। दिस काइंड ऑफ शेड्यूलिंग इज नोन एज नॉन प्रीएम्प्टिव। And if you look carefully at case number 2 and case number 3, running से ready में हम जब भी process को भेजते हैं, that we used to do forcefully always, either because of any higher priority or any interrupt or maybe just because of the multitasking systems. तो इस केस में कभी भी प्रोसेस अपनी मर्जी से सीपीयू को नहीं छोड़ता। वी ऑलवेज यूज टू वेकेट द सीपीयू और वी ऑलवेज यूज टू वेकेट द प्रोसेस फोर्सफुली फ्रॉम द सीपीयू। And similarly, the case number 3 is also the same category. Whenever a process went from waiting to ready, so in that case also we will always assume that it is a forcefully evacuating of the CPU for that particular process which is currently executing. So जो case number 1 and 4 हैं, they are known as non-preemptive scheduling, जहाँ पे process अपनी मर्जी से या तो CPU छोड़ेगा या फिर वो पूरा execute हो जाएगा। लेकिन second case and third case are the cases which are known as preemptive scheduling, and in the case of preemptive scheduling we always used to have the processes, we used to vacate the processes forcefully from the CPU and either we send it back to the ready state or we used to have some other procedure for that particular processes. So this is the concept I want to discuss with you people. So you must know the difference between the preemptive scheduling and the non-preemptive scheduling. Non-preemptive means once a process is allocated to the CPU, either the process will terminate itself or it will leave the CPU by its own wish to perform any input-output operation. But preemptive scheduling is we are forcefully going to vacate the processes from the CPU due to any reason. So this is the difference between preemptive and non-preemptive scheduling. And in the next few lectures, we are going to discuss many important algorithms on the basis of non-preemptive or preemptive. So last topic is what is dispatcher. So dispatcher is another component involved in the CPU scheduling. And basically you can see in the process state diagram, dispatcher is actually the entity which actually picks the process from ready state and dispatch it to the running state. So ये काम किसका है? Dispatcher का. Scheduler का क्या काम है? चूज कर लेना कि एक प्रोसेस किसी भी बेसिस पे, किसी एल्गोरिथम के बेसिस पे उसने चूज कर लिया. इफ वी आर हैविंग 5 प्रोसेसेस P1, P2, P3, P4, P5, सो सपोज CPU शेड्यूलर ने P4 को पिक किया. जैसे ही वो पिक हुआ, डिस्पैचर का काम क्या है? उस P4 को पिक करके रेडी स्टेट से रनिंग में ले जाए, यानी कि CPU is allocated to that P4 processes. So this is the task of this dispatcher. So dispatcher is a module that gives control to the CPU, to the process selected by the short-term scheduler, and it includes some other important tasks such as context switching, switching to the user mode, and the time which any dispatcher takes to stop one process and start another process is known as the dispatch latency. So this is all about today's lecture, and I hope you have enjoyed this lecture, and it consists of so many new interesting things. I have talked about the basic concepts of scheduling, CPU scheduling, various types of schedulers, including long-term scheduler and short-term scheduler. Then we have seen what is degree of multi-programming, what is a CPU bound process, what is input-output bound process. Then we have another kind of scheduler, that is medium-term scheduler. We have learned what is context switching, and now this particular last slide is very important, where we have learned what is the difference between this preemptive scheduling and non-preemptive scheduling. So in the next lecture, we will study some important parameters, criteria for the scheduling algo, and then we will start the various different scheduling algorithms, which are very interesting and one of the most important topic of this process management. So I hope the things are clear, and if any student feels to have any doubt, you can simply ask.